Hey guys, welcome to our video on how to find percentiles and why they are important. A percentile is a value that is the dividing line between X percentage of the population and the remaining Y percentage of that population. The 70th percentile would be a number separating the lower 70% of a population from the upper 30%. This information is valuable in many of the statistical calculations we do in class, as well as for evaluating how individuals, machine parts, or anything compared to the rest of the population. Here we have a pair of generic graphs that represent the PDF and CDF of any function f of x. The CDF is what we're interested in here, as we know that if we select a value a and plug it into the CDF, we will obtain what percent of the population is equal to or below that value a. You might notice that this is our definition of a percentile. Therefore, we are able to calculate percentiles for a function f of x by first calculating our CDF. The CDF is defined as the integral of the PDF from negative infinity to our desired value a. However, when we are looking for a percentile, we don't know what value a we are looking for.
In order to show you how to find this value a that equals our desired percentile value, we have this example. We are given the PDF, and we're at the PDF here. Our PDF, and we're asked to find the 95th percentile, which is here. So we know that our first step is to integrate this PDF function from negative infinity to a. Since the lowest value where probability exists is 1, we substitute 1 for negative infinity right here. After finding this integral, which is now this equation here, we then set it equal to 0.95, which is the percentile we are looking for, and solve the algebraic equation to get our desired value of a. We now know that 95% of weeks will have a demand of 1966 thousand gallons or less. Now, if we desire to know what the 80th percentile would be, we would have set our equation here equal to 0.8. Right here, this would be 0.8. And we would have solved for a with this new value. This method of finding the CDF and setting it equal to its desired percentile will work for any continuous function there is, including distributions such as beta, Weibull, and log normal. As long as we're able to find the CDF, or we were given the CDF, we can find the percentile for that given distribution.
For any normal distribution, we do not even need to find a CDF as long as we have a z-table. If we know the mean and standard deviation of the distribution, then we can use this equation to find whatever percentile we wish to know. We'll demonstrate this using this example. We first go to our z-table and find the z-value closest to 0.85 on the table, which turns out to be z equal to 1.04. We then multiply our standard deviation of 1.5 by the z-value of 1.04 and add it to our mean of 50 to get the 85th percentile, which is 51.56.
This is why z-critical values and other tables are so important in our statistical analysis of populations. By using these tables, we are basically looking at a reference table of percentiles. The z-value in this graph, right here, is a number that relates the desired percentile to the standard deviation of the population. For a normal distribution, the 85th percentile will always be 1.04 standard deviations from the mean. So when we are calculating a confidence interval or conducting a hypothesis test, we are using calculations that relate our mean, standard deviation, and sample size to the percentile of the population defined by alpha. So in this instance, if our alpha was 0.05, this shaded area here would be 0.95 of our population, and the remainder here would be 0.05. So the area to the right of our z-value is the part of the population that falls outside of the critical percentile value we've chosen, and the area to the left is the portion of the population within our critical percentile. This holds true for other critical values we use, such as chi-squared and t, shown here. The numbers we obtain from the tables are simply reference values that have already been calculated that relate the desired percentile to the equation we are using. This shaded area in the chi-squared table might be 10% of our population, and the number that we find using our chi-squared table that's related to our equation and population is just a value that reflects that 10% of the population falls outside of our chosen percentile in relation to our specific calculation and problem. In conclusion, this is why percentiles are important. We use them for most of the calculations we do. It's just that they've already been calculated for us, and we can look up ratio values for a given distribution that tells us how the percentile fits into our equation.
Thank you.